Good morning, my lovelies. Well, let's hope that you got through the lesson on Friday, but more than likely you did not finish all that. So I want to go back over a little bit of piecewise functions, and you can always go back and watch that video on YouTube. Just type in Darby Stansel. That's how you spell my first name. Most people know. And you'll see it by section in part 1, part 2. So hopefully I won't screw this up today. In fact, I've built in today is shorter. That way, if you didn't get done with piecewise, we'll just add that on. Okay, so piecewise functions, basically, depending on where you're at on the x-axis, you graph a different chunk. Each chunk of the x-axis has a different rule it follows. So just pulling one out real quick from the book, f of x equals x plus 1 if x is less than negative 2. And it follows the rule negative 2x plus 3 if x is greater than or equal to negative 2. Now notice that one of these is going to have an equal sign and the other one won't most of the time because not all of them in this textbook do, but in most functions that they jump from one value to the next and they don't leave a value off. This text gives some examples where they're greater than and less than, but most of the time one of them will be an equals. So just if I said find f of negative 3, then you need to think, well, is negative 3 less than negative 2 or is it greater than or equal to negative 2? Well, since negative 3 is less than negative 2, you're going to use x plus 1. So you'll just put your value in, and it's negative 2. If I say, what is f of 4? Well, 4 is greater than or equal to negative 2, so you're going to use the other rule. Negative 2x plus 3. So negative 2 times 4 plus 3, negative 8 plus 3, negative 5. And I know I'm going to have errors in this, so if I have errors, I don't want to hear about it. It wants you to write the domain. If you were to graph this function, the magic number here is negative 2. The actual graph of x plus 1 has a y-intercept of 1, and it actually goes forever with a slope of 1. But on a piecewise function, we only care about this graph once the x values are less than negative 2, and then that's the piece of the function we start graphing. So x plus 1 would continue. So it is a line, but you're not concerned about this. So if you graph them on a graphing calculator or the Inspires, you can graph both rules, but then you need to look. You can actually maybe graph on the Inspires, you could graph x equals negative 2, and that would show you where to split each one. But I would rather you just do it on paper and know how to graph yourself. If the second rule has a y-intercept of 3 and a slope of negative 2. So, holy moly, Miss Dancel. So this one goes all the way up to here, and it's a filled in dot. And yes, the line would keep going like this, but we're only concerned with it from here on. So if it asks what the domain of this function is, there is nothing that's restricted. So on this one, it can go from negative infinity all the way to positive infinity, which can be written either like this, or you can just write the symbol for all real numbers. I'm doing something, sorry. Well, I was trying to do something. So on the ones, if they would have said greater than right here and not greater than equal to, your domain in interval notation, well, let's just do one real quick, it's faster. Let's say f of x is linear. It's x minus 4 if x is greater than 4. And we'll just say 2x if x is less than 4. So we don't need to graph this as much as realize that they're telling us the rules, where they're telling us we can take any number greater than 4 and we can take any number less than 4. But we can't actually take the number 4 itself. So the domain of this would equal from negative infinity to the number 4. It would skip over the 4. You would union that with 4 to infinity. So that's enough about piecewise function. It can be more than 2 rules. I know in your book they only showed 2, but you could have 3 or 4 rules, like the example I showed yesterday with, steps, or a lot of times on sales positions, the more you sell, the higher the percentage you get of your sales. So they might have several different tiers of the functions that are your pay. I can't talk today, sorry. Okay, today, 3.3. The big deal for today is rates of change. When you were young, you called this slope. But you always thought of slope as far as just a line. And a rate of change doesn't have to be associated with just a line. Okay, I'm back. I took a break and drew a graph. I'm struggling. Rates of change don't have to just be slope and be a straight line. I could figure out how much something changed from this point to this point. And notice that's a pretty flat line. From this point to this point, it's getting steeper. From this one to this one, it's getting quite a bit steeper. And I could have even went from here to here, and that's the steepest rate of change. I also could have found out the overall rate of change, which would be not indicative of how fast this product is making profit currently. So rates of change are just basically how much is something going up over a period of time. How much is a function increasing per, you can say unit. It can be just X values, or it could be months. It could be thousands of dollars. It could be all kinds of stuff that you're putting to hours of exercise. But it's just rise over run. When you were young, you were taught rise over run. We're going to get a little bit pickier than that. You were also taught y2 minus y1 over x2 minus x1. I taught my algebra kids delta y over delta x. And remember that the Greek symbol, uppercase symbol for delta, means change in. So you're changing your y over your change in your x. There's 2 parts to calculus. One's integral calculus and one's derivative calculus. The differential calculus, that's the same as derivative. The differential calculus, the whole thing, it deals with rates of change. It wants to know how one quantity is changing over time, or the rate of change at a specific moment. So that's what calculus does. The other area of calculus teaches you how to find the area under curves or in volumes. So, okay, now In functions, your y, which is also your dependent variable, in my above graph I sketched, it would have been the profit. The dependent variable can be written as f of x. So slope I'm old, I'll keep saying slope often. So your formula for slope, y2 minus y1 over x2 minus x1, actually becomes f of x2 minus f of x1 over x2 minus x1 when given the points x f of x1, x1 f of x1, two parentheses. That'll happen a lot. I forget to write a second parenthesis. And x2 f of x2. So this is what you always did in junior high and Algebra 1, maybe even in Algebra 2. But in college algebra, in function notation, the rate of change is your dependent value, the height of your second function minus the height of your first function over your initial your independent variable of your first function minus your independent independent value of your second and first. Told you I'm struggling. I know I can hear you making fun of me right now. So let's practice. If I can get there. We're gonna just work on some odds and or some evens. I'm not gonna do the odds; those are yours. And you guys then will do the odds. We're gonna start with number 6. The function given to us is g of x equals 2x squared minus 9. And then they tell us that they want to know what its rate of change would be from 4 to b. Now let's look at what this means. It means on the number line, from 4 to whatever b is, how much would this function, what is its rate of change? Okay, so this is so different from anything you've ever done with your traditional slope values that it would really help you to start out by just thinking about what all four pieces of my phone is going off, I'm sorry, what all four pieces of your slope formula or your rate of change formula are. Let's start with x2. That's going to be the larger of the two numbers on your interval. This is basically saying from 4 to b, if you had a function, what's its rate of change between here? So we don't know what b is. It could be a bazillion. It could be, we do know it's larger than 4 because the way they've set it on the interval, this is saying from this point to this point, what is the rate of change? Now that could have went like this. We don't know what the actual function did, but we know that it's going from here to here. What is its rate of change? So x2 is the larger number, so it's b. x1 is your smaller number, 4. F of x2 has to follow the rule. Oh, it's a g. It's a g. G of x2, you would put, since x2 is b, this is going to be whatever g of b is. Well, g of b would be 2 times b squared minus 9. g of x1 will be whatever x1 is, so g of 4. So that'll be 2 times 4 squared minus 9, which is 23. So now, using these four values, we're going to replace, our formula looks like this, x2 f of x1 over x2 minus x1. So g of x2 is 2b squared minus 9 minus f of x1, which is 23, over x2, which is b, minus x1, 4. So there's the four components. Simplify. You get 2b squared minus 32 over b minus 4. And I'm already excited because I can see that the 2 is going to factor out. Let's come back over here. 2 is going to factor out. You get b squared minus 16 over b minus 4. Hopefully you're as excited as I am to get to go, wah, pretty soon. 2 times b minus 4 times b plus 4 over b minus 4 is 2b plus 8. That's your final answer. That is the rate of change that that function is going from 4 to any given b if it follows this function rule. And it wouldn't matter what b is. You could say b is 10. Well, if that's the case, then this would be 2 times 10 plus 8, 28. If that's a million, this would be 2,000,008. So it really doesn't make any difference. So I told you, this is slope. That's all you're doing. But it's slope with a twist. So it'll get better. Let's keep moving on here. Number 8. Sorry, I turned my page. K of x is 4. The rule is 4x minus 2. Remember I said the other day, just think of putting a function as a machine. You put a value into it and you get out a value. What I was talking to Advanced Algebra 2 about today in class was how sometimes they're having trouble seeing that variables are also numbers. So this interval is 3 to the value 3 plus h. So it's h units further to the right than whatever 3 is. So if I took 3 steps to the right, it would be at 6. If I took 10 steps to the right, it would be at 13. But the rule is going to work for however many steps you are to the right of 3. So we're going to have k of 3 plus h minus k of 3 over 3 plus h minus 3. Those are the four components. Your function with the larger input minus your function with the smaller input over the larger input minus the smaller input. And then you actually will substitute those values into your rule, 4x minus 2. Be really careful. Be liberal with your parentheses. You're going to hear me say that an awful lot. Be liberal with your parentheses. The rule, the function, k of 3 plus h, you will put a 3 plus h in to x's spot. Now think, this is just the first one. This is what k x sub 2 is. Minus what you get when you put a 3 in. The rule is 4 times 3 minus 2. The bottom's easier, because the bottom, that was a very ugly line. You know I'm going to have to fix that, guys. Sorry. Okay, I did it again. So now you know I can't write it on a desk. So the bottom rule is going to be real easy. You've got 3 plus h minus 3. It's just going to be h. Simplify. 12 plus 4h minus 2 minus 12 minus 2, 10. I didn't need parentheses, over h. 12, hey, that's pretty cool. you get 4h over h, and your slope is 4. Now, when you go into calculus, and I hope some of you do someday, because most people who end up going into calculus and enjoying it end up with good jobs, to be honest. Or lowly jobs like high school math teachers, but loving their job, so that's all that matters. When I get back, I'll kind of tie some stuff together, because this is what we've just done is something called the difference quotient, and it's pretty magical, and you'll use it a lot in calculus. Then you'll learn a shortcut called the derivative, and you'll wish you never did this again in your life. So let's do number 10. Some of these get pretty hairy. G of x equals 3x squared minus 2 on the interval. They want to know on the interval we are going from x to whatever x was plus h units forward. Okay? So just picture an x-axis. Whatever, if they told you x was 7 and they told you h was 5, then you'd be going from 7 to 12. 7, and then 7 plus 5 is 12. But this is what makes math harder for some people, is whenever you leave the variables in it, you're thinking about it more abstractly, and it would work for any steps. It would work for any chunk of that any interval along the x-axis you want, not just from 7 to 12. Once you get that rule for the rate of change for this function from any given x to h units past x, then that rule, since you've used arbitrary values that can change, that rule will work to find the rate of change anywhere along that function. So that's pretty magical. So here we go. First one, remember you're going to have g of your second value, which is x plus h, minus g of your first value, h, over your second value, x minus h, or x plus h, minus your first value. So that's going to become, now actually putting x plus 8 into your function, that's going to become 3 times, don't forget, be liberal with those parentheses, x plus h, quantity squared, minus 2. That's all what this is. I meant to get some highlighters and highlight, but oh well. Minus whatever g of x is. So you're not even having to change it. G of x is just 3x squared minus 2. A lot of room for error right there. If you do not put parentheses around this value, you won't distribute this negative sign and you'll mess it up. X plus h, or minus x is just the h. So now we have to clean it up. First I'm going to do square the binomial, leaving parentheses. I have x squared plus 2xh plus h squared minus 2. And I can also go ahead and distribute this negative sign. So minus 3x squared, negative times negative is plus 2. That got me excited, because do you see the minus 2 plus 2? I can go, wah, wah, right there. Over h. Distribute 3x squared plus 6xh plus h squared minus 3x squared over h, wah, wah, equals, I'm going to factor an h out, and I get 6x plus h over h, wah, wah, equals 6x plus h. And you're going to find out something cool about that h that hung on for a while in a later math class, and hopefully I'll get to talk to you about it later, but it's kind of confusing. So it's pretty important what you've just found. If you guys will remind me when I come back, I'll pull this video up and kind of point to a couple things and show you how easy it would have been if you knew how to do a derivative. So Two more problems. 12. B of x equals 1 over x plus 3. And we're going on the interval from 1 to 1 plus h. I will say this is the only college algebra book I've ever taught out of that has you do this, and I'm really glad because it's got a lot of use to it. I just glanced at my computer and I've received 16 text messages since I started doing that. That's why my watch keeps dinging. So sorry about that. So let's go ahead. Since you can see the pattern that we keep doing on these, each time we're going to take the function with the second input minus the function with the first input over second input minus first input. Well, let's just go ahead and substitute those values in right now. So my x in the first one is going to be 1 plus h. And I've got a plus 3. Don't forget him. Minus what I get when I just put a 1 in here. 1, I better write it down. 1 plus 3. Over my first value, or my second value, 1 minus plus h minus 1. Sorry. So let's simplify that before we have a complex fraction here, so we will have to make it as one fraction. So we have 1 over h plus 4 minus 1/4 over h. So we need to make this into one fraction. So use your identity element. This guy's missing the factor 4. This guy's missing an h plus 4. So we get 4 minus, mind this sign right here, that'll really mess you up if you don't distribute that as you go. 1 times h is h, but it's negative, so negative h. 1 times 4 is 4, but it's a minus, so minus 4 over h plus 4. And let's go ahead, this is when you divide fractions, you change them to multiply. I'll go ahead and show that step, just so you won't get confused. So we ended up with negative h over h plus 4 times, when you flip that over, it'll be 1 over h. Final answer. 1 over h plus 4. Negative 1 over h plus 4. So, last one. I'll let that sink in a little bit. That one's kind of crazy. It was a lot easier back when it was just like 4 minus 7 over 2 plus 3, wasn't it? I haven't even verified if I'm doing all these right, so let's hope I am. R of t equals 4t cubed. Ooh, love cubing numbers. Oh, I really don't like cubing numbers. This is not going to be the most fun. Well, I'm going to like it, but I don't know if you guys are going to like this. 2 and 2 plus h. Okay, so we're putting a 2 plus h into the function. Our second value goes into the function first. So 4 times 2 plus h cubed minus the first value put into the function, 4 times 2 cubed, over second value, 2 plus h, minus first value. And that's not a coincidence, by the way, that it keeps happening like that. At this point, there's a theorem called the binomial theorem. You've probably never used it, but there's a fancy way that uses Pascal's triangle that you can expand that really fast, but that's for a whole nother day, I think. So we're just going to do it we're going to come over here to our scratch paper and think about what it means to cube 2 plus h. I was just talking to a student about this after school. It just means that times that. So this would be 4 plus 4h plus h squared. First, outside and inside are the same, so that's the 4h last. Times another 2 plus h. Be methodical. You've got 3 terms times 2 terms, so you'll end up with 6 terms. 4 times 2 is 8. 4 times h is 4h. 4h times 2 is 8h. 4h times h is 4h squared. H squared times 2 is 2h squared. H squared times h is h cubed. It made it easy for me to line them up if I put them like that. So there we go. When I take 2h times itself 3 times, that's what I get. Often people just say 8 plus h cubed. But you have to, don't forget about all the middle components that are coming together to make that middle part. So, we've got 4 times this. Minus 2 cubes 8, 32. Over h. So that gives us 32. Woo! Plus 48h plus 24h squared plus 4h cubed minus 32. And now you can see why I went woo-woo over h. If we factor an h out of all of those, you'll be left with 48 plus 24 h plus 4h squared over h, which just becomes 48 plus 24h plus 4h squared. That's a doozy. I hope you like that one. That one wasn't quite as easy to do, like to take a derivative of. That one wouldn't have been quite as easy. So anyway, your assignment would be to finish your piecewise functions and then add add 5 to 17 odd. So finish the second part of that assignment, which would have been of your 39 to 53, the piecewise on 3-2, and then do 5 to 17 on 3-3, and these of course are all odds. Okay, so it's Tuesday. Give me a call if you guys are bored, because I'll be bored probably. All right, if you have questions during class or like the next class period, if you come back and you need me to take a picture, write out one of them and send it to you, I'll do that. I'll try to get answers to Miss Bose or give her access so she can look at the answers on the computer. So, all right, be good, kids. Thank you, thank you.